Well, hi guys. Now I will show you because some of you have asked me what kind of driver I have used to build this flyback transformer. So this is the driver and this is the transformer, the flyback transformer from a CRT TV. And basically this is the schematic, but I have modified for some reasons. Is not the same, but the principle of the transformer is this. The primary coil, the feedback coil, and the output coil. So you can also build this with lamps, vacuum tubes. This is with transistor. This is with a PNP transistor. So this is the first impulse that is generated. Well, let me explain my driver. So, first I've designed this power supply, those cables, those wires, sorry. I have recycled from a PSU device inverter that automatically turn on when the power goes off. So I grabbed those high gauge cables, wires, and used those 42 volts, 2200 microfarad each, and I put them in series. So 42 and 42 equal 84 volts. So this is neutral, this is positive, this is the bridge between minus and plus of this, the other one. This is the negative that is connected to the minus, and those are the leads. The ground doesn't need it. This is silicon high temperature wire that is used in stoves, high calorific stoves. This is blue and this is brown. That goes here and goes in this from this nylon cable into this silicon wire, goes here. It turns on the fan, that is a 12 volt fan that can run even in 24 volts for high speed if this gets hot. So with the voltage increasing, increase the voltage in this motor and also increase the current and also blow faster the heat sink. So the driver works like this. This is a voltage divider. As you can see, before I explain the voltage divider, I want to show this brown wire that goes into this 1, 2, 3, 4, 5, 6 turns of primary coil and is ended up in this transistor collector, as you can see here. This is transistor collector. I have connected those transistors in parallel. So 2 transistors in parallel for high current. High current is good for those transformers because it's great for high voltage, because it's fully fulfill this coil with magnetism, electromagnetism, and it produces a large scale of high voltage. in this high voltage lead. This is the ground that I have connected in this transformer ground, not in the ground of the transistor, because I don't want to burn this by high voltage, so I separate it. And that circuit works like this. The voltage that came from the power supply gets divided by those 220 ohms and 22 ohms resistor, so it's a divider, and the divided voltage goes here in this coil, 3 winding coils, because it's the pulse generate a voltage here, and if I don't use this here, it can burn up the transistor base. So this gets heated up because this limit the current that goes to this base, but also this voltage have AC inside, because it gets the pulse of the transformer feedback and goes to base of this transistor. When I mean one transistor, I have both of them in mind, so because they are parallel. And this capacitor here, 100 nano, and this diode, fast diode, that is not connected here like this with this resistor, but is connected here between collector and emitter, also the diode. So this is simple. Those are BD249C, so is a high current transistor. As I remember, is 49 amps or 40 amps, something like that, and 80 amps both, so it's high current. Well, this is simple, very simple driver. Let me turn on to see. But before I turn on, I want to explain this and this transformer that also got it from a PSU, power supply unit, automatic inverter. So let's begin with this. I have those since I was kid. I have saved those. Those I have bought. And I have created this cable to test things fast. And now this is a transformer. It's not just a normal transformer. It's with 2 high current leads and is center tapped. So I have used those both without using the center tapped one. So I've put those in this connection in an AC to DC bridge rectifier, KBPC 3510, so it means 35 amps 1 kilovolt diode, so you can use it in main voltage and also in low voltage. I've used those wires for protection like a fuse, because those are in a big gauge. Let me see here, 10 AWG American wire gauge, 10 American wire gauge, so it's 600 volt, sorry, and 105 degrees Celsius So also these are not just simple inputs. This is neutral, and this is also an auto transformer. So this is for low voltage, this is for 30 volts, this is for more low voltage, sorry, more high voltage, but it heat up the coil, so I don't use this and this because it's too low. This is when the voltage is 110 volts or something else. So I basically use this or this. Now I will show you how I connect it. So I use this bridge rectifier, and I see here it has an AC and a plus. So basically the diagonal reverse are, this is AC, so also this need to be AC, and this is positive, so the other one here in diagonal is negative. Well, let's put the positive on. And the negative here. So I have connected, but be very carefully because this is high voltage. So I will use this sword. That's a kid toy, but it's polyethylene, and is 1, 2, 3 hands and half larger. So is a lot to protect yourself from this high voltage, so it may be jump. Let me make it ready to tell you. So I did it. I safely connected those main input income. So I will carefully move. I will turn on this, but I will be carefully. I will check something. I be careful to not use things that get shorted, because high voltage is dangerous. It can kill you instantly. And be careful from those leads. Those are also high voltage. So to protect my book first, because I love books. So I need to move. I get it up. I will see what was this noise. Sorry guys. So it wasn't nothing. Let's turn on the power. As you can see, it arcs. It arcs here. It jumps. It's generating ozone and is smelling bad, as you can see here. So as you can see guys, the voltage is higher. So guys, the voltage is higher. Let's measure it. It can penetrate even this board. The Tarek's at 7.5, 6.5. Because something is arcing in this table. This Lichtenberging. Look how it's burning. It's burning the wood. Well guys, have a nice day. Don't forget to subscribe, share, like, comment.